Solving simultaneous equations using row reduction. Given AX is equal to B, where A represents the matrix of coefficients, we can solve these equations by first forming the augmented matrix A vertical slash B, and then reducing this matrix to echelon form. Let us see how this works. All right, so to the right here, we sort of have the preliminary steps. First, we have to represent the information as a matrix equation of the form AX is equal to B, where the matrix A is the matrix of coefficients. Then we're going to form the augmented matrix A vertical slash B, and then we're going to reduce the augmented matrix to echelon form, to row echelon form. All right, so let's start. Let's represent our information as a matrix equation of the form AX is equal to B. So we have 3, 1, 2, 2, 4, 3, minus 1, minus 5, 1. So that's A, which is the matrix of coefficients. Then we have X, Y, and Z. And this is equal to whatever is on the right, 11, 7, and 9. All right, so now this is the form A, X is equal to B. So next we're going to form the augmented matrix A vertical slash B. So the augmented matrix A vertical slash B. And here we're going to have 3, 1, 2, 2, 4, 3, minus 1, minus 5, 1, vertical slash 11, 7, 9. All right, so and now C now we're to reduce the augmented matrix to echelon form. All right, so let's make the first elements of the second and the third row be 0. So let's start with row 2. Row 2 is going to be 3 row 2 minus row 1. And row 3 is going to be 3 row 3 minus 2 row 1. All right, so let's start off with row 2, 3 row 2. So this is 3, 12, minus 15, 21. That's 3 row 2. And we're going to minus row 1, which is 3, 2, minus 1, 11, subtract. And we're going to get 0, 10, minus 14, and 10. All right, row 3, 3 row 2, sorry, row 3, 3 row 3. Three row 3 minus 2 row 1. So 3 row 3, we have 6, 9, 3, 27. Minus 2 row 1, we have 6, 4, minus 2, 22. Subtract, we get 0, 5, 5, 5. So this is where we're at now. We have 3, 2, minus 1, 11. Row 2, 0, 10, minus 14, 10. And row 3, 0, 5, 5, 5. All right, so next let us make the middle element of row 3, 0. So we're going to have row 3 is 2 row 3 minus row 2. So 2 row 3, we have 0, 10, 10, 10 minus row 3, 0, row 2, 0, 10 minus 14, 10. So let's subtract and we get 0, 0, 24, 0. So right now we're here. We should be at 3, 2, minus 1, 11. 0, 10, minus 14, 10. And row 3, 0, 0, 24, 0. All right, so next we're going to get all the leading diagonal elements to be 1. So we're going to have R1 is going to become 1/3 of R1. R2 is going to become 1/10 of R2. And R3 is going to become 1/24 of R3. All right, and so where we should end up is 1 2/3, 1/3, 11/3, 0, 1 minus 7/5, and 1, and lastly 0, 0, 1, 0. All right, so we're going to move back from row echelon form to 1, 2/3 minus 1/3, 0, 1 minus 7/5, 0, 0, 1 times x, y, z is equal to 11/3, 1, 0. So let's go back now to Cartesian form. In Cartesian form, we're going to have x plus 2/3y minus 1/3z is equal to 11/3, equation 1. We have y minus 7/5z is equal to 1. This is equation 2. And z is equal to 0. This is equation 3. All right. So let's solve. So we have z is 0. So we have y minus 7/5 times 0 is equal to 1. So y is equal to 1. So y is 1, z is 0. We have x plus 2/3 times 1 minus 1/3 times 0 is equal to 11/3. So we're going to get x is equal to 11/3 minus 2/3, which is 9/3, which is 3. So solutions of our equation are x is equal to 3, y is equal to 1, and z is equal to 0. All right, let's see if we can do it again. Let's have a look at the next example. All right, example 47. So let's start out by writing, representing our information here as the matrix equation. We have what? 1, 2, 2, 4, 3, 1, minus 5, 1, minus 1, x, y, z, and this is equal to 13 minus 1, 1. So we've just written our matrix equation in the form A, x is equal to b. All right, next we're going to form the augment matrix A vertical slash b. So A vertical slash b. 1, 2, 2, 4, 3, 1, minus 5, 1, minus 1, b, which is 13, minus 1, 1. So next we're going to reduce to row echelon form. In row echelon form, the legal diagonal elements must be 1. All the elements below the leading diagonal must be 0. So I need to get all the leading diagonal elements to be 1. The leading diagonal goes from top left to bottom right, and all elements below that are supposed to be 0. So that is my aim. R2 is R2 minus 2 times R1. So the objective here, my starting objective is to make the first element of row 2 and the first element of row 3 0. So in my first 2 row reduction operations are to make the first element of row 2 0 and the first element of row 3 0. All right, so a similar thing for row 3. Row 3 is row 3 minus 2 times row 1. So row 2, 2, 3, 1, minus 1, 2 times row 1, 2, 8, minus 10, 26. And we are subtracting 0, minus 5, 11, minus 27. Row 3, 2, 1, minus 1, 1, 2 times row 1, 2, 8, minus 10, 26. We're going to subtract 0, minus 7. This is 9, minus 25. All right. And so my new situation is 1, 4, minus 5, 13, row 1, row 2, 0, minus 5, 11, minus 27, and 0, minus 7, 9, minus 25. So next we're going to make the second element of row 3, 0. And to do that, I'm going to have 5, row 3 is going to become 5, row 3, minus 7, row 2. So 5, row 3 0 minus 35, 45, minus 1, 25. So that's 5 row 3 minus 7 row 2 and this is minus 189. And I'm subtracting 0, 0, minus 32, and this is minus 64. So my new standing, 1, 4, minus 5, 13, 0, minus 5, 11, minus 27, 0, 0, minus 32, minus 64. All right, so next I'm going to make the leading diagonal elements become 1. All right, so row 1 is okay already. Row 2 is going to become minus 1/5 of row 2. And row 3 is going to become minus 1/32 of row 3. All right, so this will bring me to 1, 4, minus 5, 13, 0, 1, minus 11/5, plus 27/5, then 0, 0, 1, and minus 64 divided by 32 is 2. So from here now, back to matrix equation form. This is the same as saying 1, 4, minus 5, 0, 1, minus 11/5, 0, 0, 1, multiplied by x, y, z, and this is equal to 13, 27/5, and 2. So with that in mind, let's get my 3 equations. My 3 equations are x, 4y minus 5z, x plus 4y minus 5z is equal to 13, equation 1. Y minus 11/5z is equal to 27/5, equation 2. And z is equal to 2, equation 3. So since z is 2, I can say that y is equal to, y minus 11/5 times z, which is 2, is equal to 27/5. So therefore, y is equal to 27/5 minus 22/5, which is 5/5. Y is equal to 1. So now that I have y and I have z, I can say x plus, what is this? X plus 4y. What I have is 45 here, but it should be 4y. x plus 4y, which is 4 times 1 minus 5 times z, which is 2, is equal to 13, equation 1. So this is 4 minus 10 is minus 6. Minus 6 goes over and become positive. So x is equal to 13 plus 6. X is equal to 19. So my solution is x is equal to 19, y is equal to 1, and z is equal to 2.